Hello students, good morning. Myself Rajesh, Zoology faculty. Right. Today I came to here to give you a demo regarding breathing and exchange of gases. Given that the topic of respiratory volumes and capacities. Right. As you know that it is very important for Neet also. And many of the students struggling in the topic about find out of respiratory volumes and capacities. Okay, right. And today I would like to give you about the respiratory volumes and capacities complete information with the easy manner. Right? Listen to me carefully. And in this chapter, there are different types of volumes we have. Right? Just about normal inhalation and normal exhalation as we are doing now. Good. Right? In some time we can do forcible also. Right? It means forcible inhalation and forcible exhalation, right? This is what one kind. It's about normal and forcible. Good. And another one also say that is if we can do forcible expiration also, right? There is some amount of air which is always remaining in the lungs, right? That is also one kind of volume, right? If we can find out the volumes, definitely we can find out capacities also, respiratory capacities also, right? So first we have to find out volumes and next we have to find out capacities, right? So today topic about respiratory volumes and capacities, right? Let me start today. Right? So respiratory volumes and capacities in this topic, right? First we have to find out volumes, next we have to find out capacities, right? So in these volumes, like in normal, like in the breathing, right? So what? Inspiration and expiration, or inhalation or exhalation, right? So in the way that a normal healthy man can inspire or expire almost 12 to 16 times per minute. Okay, a normal healthy man can breathe almost how many times? 12 to 16 times per minute. That's it. Everyone know about it, right? Good. So okay, we are breathing as we are a healthy man 12 to 16 times per minute. That was good, right? Next, what I want to tell you, right? Next, what I want to tell you is, here in this chapter, definitely we have to know about what are the devices we have to use for that measuring of the respiration, right? Meter respiratory volumes and capacities. That is nothing but respiratory rate, right? How could we? What is the device, right? I'm going to tell you that, right? Device which is using for the find out of respiratory volumes and capacities is one, like spirometer, also called as respirometer. Okay, this is what. Right, all of you? Spirometer or respirometer, right? So we have to know one thing. How could they find out, right? I will show you that device, how it is look like, right? Listen, you can see here. Just imagine this is a device I'm drawing here about spirometer. It's about. Okay. Right. Right. This is the device of spirometer or respirometer. You know what we have to do? Just we have to we have to fill the air into that, right? And by that the ball should be moved to here, right? So in normal element, definitely they will be moved. They will be moved up, right? So if the balls are not moved, mean they are not moving. There is no moving in that. It's difficult in the moving. Or if they are reaching up to here only, definitely the person who is getting difficulty in the breathing. Got it? So this is what the device of spirometer or respirometer. Got it? So this is about spirometer or respirometer to find out. Spirometer, you know what is meter spiro? You already made in classes about cockroach respiratory system. Like it consists of 10 pairs of spiracles. You know, spiracle. Spiro means what? The meat of spiro here. Why they are giving spirometer? Breathe, or breathe, whatever. It's not right. It's about spirometer, breathe. Hence, this is called as a spirometer. It is analyzing about the pulmonary volumes and capacities. Hence, it is called as a respirometer or spirometer. Got it? This is about information of introduction, right? Almost as you learned about it. How many times we can respire per minute? 12 to 16 times per minute we can inspire or expire in the normal way only, and that too it should be the person should be normal healthy man, not a difficulty, not a person the person who is difficult in breathing, like even asthma, bronchitis, emphysema, they may not unable, mean they are unable to like respire properly because of there is a breathing difficult, right? So that is one. So I'm talking about normal healthy man. That's about introduction of respiratory volumes and capacities. Good. And next one, we have to move to that different types of respiratory volumes and different types of capacities. What? First, we have to find out respiratory volumes, right? So let me talk about today. First one, respiratory volumes. Right, students, I'm telling you here different types of respiratory volumes, right? In the first one, okay, I'll write it here, right? So first one, tidal volume. Got it? Right? And the second one, inspiratory reserve volume, right? And third one, expiratory reserve volume, and fourth one, that's about residual volume. Got it? Right? These are the different types of respiratory volumes, right? And next one, capacities. What are the capacities are they, right? And even we have discussed about another value which is not included in our NCRT, right? I'm giving you, right? That's about dead space volume, right? Okay, then it's about volumes. And next one, capacities we have discussed, right? So first one, inspiratory capacity. Good. And the second one, expiratory capacity. Right? And next one, functional residual capacity. Good. And the fourth one, you know what? It's about inhalation, right? By the forcible and the exhalation. right? So that is about even tidal volume as we have here, right? I will show you that. Here I can see that these are the different capacities we have, right? And the different volumes we have, right? So here, total lung capacity, right? And the last one is about vital capacity. These are the different types of capacities as I showed you now. You can see here, right? These are the different types of values. These are different types of capacity, right? So let me discuss about first one today about the volumes. Okay, right. So before that, we have to draw the diagram of that. We have to draw the diagram, right? So same diagram what I'm drawing here, right? So here it's about I will show you here also, right? Here you can see that these are the lungs values we have to find out, right? Up to 6,000, right? So that is what I'm showing you here. Okay. Right. Right. 1000 ml, 2000 ml, 3000 ml. Next one, 4000 ml. And next one, 5000 ml. And finally, it's about 6000 ml. Right. This is what lung capacity, total lung, right? Total lung capacity, right? Right. So here, first one we have discussed about the what? Here, one. What is the volume? Tidal volume, right? So I'm going to tell you now. What is the tidal volume? Listen to me here. This is what. So it's always it's a graph like, right? It's a graph like, and it's always showing about the wave, like the graph, either in the upward, either in the downward, right? So first one you have to find out like a deflect. What you have to call for that? Deflect, right? The way it's about the upward deflect in the case of what? Inhalation or the inspiration, right? Now our lung thoracic volume will be increased. Definitely the graph should be up, right? So that is what upward. Whenever it is inhale, the graph should be upward, right? Whenever it is exhale, the graph should be downward. That is what we have to discuss right here. Listen, first one, tidal volume. I would like to discuss it today. Tidal volume. Tidal volume means what? Right? Volume of where a person can inspire or expire by normal breathing, means normal respiration, like what we are doing now, right? Without knowledge of us, means without conscious, right? So we are doing what? Like inhalation and exhalation. That is what normal. Got it? So normal breathing or normal respiration is called as tidal volume. Got it? So here we have to write about it. If not, we can write in another slide, right? What is the tidal volume? Tidal volume is what? volume of air a person can inspire or expire by normal respiration. That is what tidal volume. You know what? How much we are inhaling, how much we are exhaling in the normal way? That is about 500 ml. Got it? So it's meant what? Tidal volume, right? So it's meant TV equal to how much? 500 ml. Got it? So here we have to discuss about that. Right? So as usual, in normal inspiration, definitely in the case of inspiration, the graph should be upward. Right? In the case of expiration, the graph should be downward. Right? It is okay in the normal. Right? If you have forcible breathing, the graph should be upward more, right? Like this. Right? If we are like it's okay after forcing inspiration, definitely we can do normal because that's about, right? If you want to do, it's about okay, it's okay, it's about forcible, right? Okay, up to here, good. So this is what expiration normal, right? The graph should be downward, right? So it's what mean the more deeper, right around, right around. That is what. So that is the way we have to use here, right? Good. Right here. Let me use about the first one for today. Right? Tidal value is about inspiration, expiration, inspiration, expiration. Got it, students? This is what tidal volume means. We are inhale, we are exhale. We are inhale, we are exhale, and the two in the normal way, as we mentioned here. As we mentioned here, right? So, can inspire or expire by normal respiration. What you are doing now. Got it? That's it. All about the tidal volume, right? How much? 500 ml. Mean you are breathing or breathe out now. How much in normal way? 500 ml. That's it. Over. Good. And next one. Tidal volume is over. And tidal volume equal to how much? 500 ml, as you mentioned there. Good. Over. And next one, we have to move to that. Second one, what? Inspiratory reserve volume. Good. Inspiratory reserve volume means additional volume of air. What is it? Additional volume of air a person can inspire or expire by normal, right? Additional volume of air a person can inspire by forcible inspiration. Do it now. Just listen. That is what the forcible inspiration. You know how much? It is approximately 2500 ml to 3000 ml. Right? So that is what we have to mention there. Right? So that is what the second one. The second one, that's about IRV. You know what? IRV means inspiratory reserve volume, right? It should be reserve, right? So that's what. Listen. So, like additional volume. You know why I'm mentioning additional? Already you are doing normal inspiration, right? If you want to know, that is additional, right? So that's what I mentioned. Additional volume of air. A person can inspire by forcible inspiration is called what? Inspiratory reserve volume. Got it? It's approximately how much? As I mentioned there, 2500 to 3000 ml. Means 2.5 liters to 3 liters of air you are inhaling by the forcible inspiration, right? All of you, that's it. It's about IRV, main inspiratory reserve value. Then how could we mention here? As I mentioned now, okay, this is what inspiration, this is what expiration. Okay, so what I'm telling you now, here I can see the additional volume, mean it should be additional to the normal, right? I will show you now. Listen. So okay, it's about another inspiration, right? So what I'm telling you now, additional, that should be additional, means from here, right? From here. That is what up to here. That is what IRV. IRV. Right? So this is what the inspiratory reserve value. So you can mention from here also because that should be additional. Got it? Okay then. Okay, after definitely after inspiration, definitely we can do what? Expiration. Good. Okay, then, good. Again, we can do what? Normal inspiration, normal expiration. That was good. Okay. This is what inspiratory reserve value over, right? Good. What is the how much total? 2,500 to 3,000 ml. Good. Over. And next one, after that, as mentioned there, that's about the ERV. ERV. Quite reverse to this. Quite reverse. You know what? Additional volume of a person can inspire by forceful inspiration. Mean here we have to do forceful inspiration like. But now it's about the forceful expression. Same matter, but we have to mention here only like we have small changes. So inspire here, it's about forceful inspiration, but we have to do a what? Forceful expression. Right? I'm writing here. Additional volume of air. Additional volume of air. Right? A person can inspire or expire. Definitely it's about expire by forceful and normal. Forcible expression. That is called as what? Expiratory reserve volume. Right? So you know what? This is what? Forcible expression. Right? So that is what ERV. It is about 1,000 to 1,100 ml. Okay, and okay then. Before that, we have to know one thing. Before that, we have to know one thing. You know what? That is about right. This is what residual volume. Before that, we have to know one thing. Before that, ERV, we have to know about RV, residual volume. As I taught you earlier, residual volume means volume of air present in the lungs even after forcible expiration. Do it now. Even after forceful expiration also, we have a small amount of air in the lungs, right? That is called as residual volume. Means volume of air present in the lungs even after forcible expiration. Means after forced expiration also we have a small amount of air. That is called as residual value, volume of air present in lungs even after forceful expiration. Very, very important line. That is called as residual value. You know how much? It's always like 1,100 ml to 1,200 ml. Right? You can't remove. Because of it's not possible after forceful expiration also again you have to expire, right? Correct? Is it possible to again now? No. That is what residual volume means. Even after forceful expiration we have some amount that is called as residual volume. That's about approximately 1,100 to 1,200. You can't remove. Even if you can remove the lungs, Even if you can throw it on the floor, if you can jump on it, you can't remove because of it's a cellular respiration. Got it? Hence, it can't be. It cannot be. Got it? It's about so residual volume, right? So, and next one. The next one, we have to mention there that graph, right? So this is what? This is what? Residual value. Okay then. How much? 1100 to 1200 ml. Mean the 1.1 liter to 1.2 liter. Got it? That's it. Good. It's about the residual volume. It's always remain in the lungs. Good. Okay, then we have to go to the previous one, like what we are reading here about ERV. So we have to do know what? Forcible expression. That's about ERV. Okay, then we have to mention that. Okay, then we know about it. It's about inspiration. It's about expression. That is good. So additional volume of air a person can expire. Definitely it should be like downwards, right? Expire by forcible expression. Do it now. Forcible expression. Got it? So this is what the ERV is about, almost 1000 to 1100 ml. Got it, all of you? This is what different volumes we have, right? And another one also we discussed earlier. What is about dead space volume? What is it? Dead space volume. You know what? I will tell you now. We have to take another slide regarding that. Just imagine here. It's about trachea, right? Bronchi, right? Primary bronchi, secondary bronchi, tertiary bronchi, right? So like that, you know very well, right? So next one: primary bronchiole, secondary bronchiole, tertiary bronchiole, terminal bronchiole, respiratory bronchiole, right? And even duct of alveoli, and finally alveoli, right? You know very well about, right? So these are the like different types of alveoli, like you know, like these are the alveoli. Okay, then we have to know one thing about it here. Students, listen to me carefully. Just imagine here. This is what we have inhaled air, right? Just inhaling up to here. It's about up to here from like from here part, right? So from the nasal chamber to almost here to here. It's about the conducting part. It's about the exchanging respiratory zone part, right? And just in the normal way, in the tidal volume, what you know how much we can get 500 ml. Okay, you are inhaling or exhaling now how much? 500 ml. Okay, you are inhaling 500 ml, but it's not reaching totally to the exchange of gases, right? So almost out of 500 ml, it's only reaching to the exchange of gases only 350 ml. Then remaining amount of 150 ml is present in the conducting part. Got it? And the volume of air which is not useful for the exchange of gases, which remains in the conducting part, that is called as dead space volume. Don't think about we are inhaling 500 ml, we are exhaling 500 ml. Okay, that's not exhaling, that's not inhaling properly because of okay, we are inhaling, but only out of 500 ml, just 350 ml is using for the exchange of gases. That's it. Only 150 ml is not even to reach to that respiratory zone. That is called as dead space volume. That is different. That is different. Okay. Right. And next one. Volumes are over. Next, we have to move to the what? Capacities. What is it? Capacities. Right. So listen to me. Here, as we discuss about different types of capacities, right? So the first one is what? Inspiratory capacities. You know why we have to discuss about capacities? Because of next one what? Capacities, right? Mean the respiratory capacities. as we didn't discuss now. Inspiratory capacity, expiratory capacity, right? Functional residual capacity, right? And next one, even what? Vital capacity. At last one, total lung capacity. There are five capacities are there. If we can add the above, what we mentioned here, if we can add these volumes, we can get capacities, which is using for the like pulmonary assessment for the pulmonologist. Okay, they will find out after the capacities only the person inability, mean the person difficulty in breathing. Got it? So okay then. First one we have discussed about capacities. In that, what is mean of inspiratory capacities? Listen to me. It's very interesting. Okay then. So in the case of inspiratory capacity, mean total volume of air a person can inspire, right? Mean, but after normal expression. First you have to do normal expression. Now you are doing normal expression. Then you can do forcible. This is what? Inspiratory capacity. Inspiratory capacity, you have to do what? Forcible inspiration, okay. But before that, what you have to do? After normal expression, mean first you have to do normal expression, then you have to do forcible inspiration. Got it? Okay then. That's what. Okay, I'm going right here. Means what? Like total volume of air a person can inspire after normal expression. That is what inspiratory capacity. So how it is possible? You have to check in the graph. Right? These are the visuals here. First, okay, you have to do forcible. Definitely from here, it should be upward. Good. Then it is after. Where? Okay, then it's okay. From here, okay, we are doing here again, right? The next one, normal expression, that's good. Okay. Capacities, right? So it's what normal expression, right? So after normal expression, from here to here, what? Normal expression, right? So after normal expression, we have to do. So here IRB from here to here, right? But from here, after normal expression, which will start from here, right? Now we have to do what? Okay, we are doing normal expression. Good. So after normal expression, we have to do what? Forceful inspiration. Good. Okay, the forceful inspiration after normal expression is called as inspiratory capacity. Got it, all of you? Me, which will be from here to here. This is what inspiratory capacity. Inspiratory capacity. That was good. Oh, could you please tell me what are the include in that IC? IC equal to what? From here to here, what? Tidal value. Got it? Very good. IC equal to TV plus from this is what? What is the zone here? What is the zone here? Right. What is the zone here? IRV, right? So TV plus IRV equal to inspiratory capacity. TV means how much? As mentioned there, 500 ml, right? Right? IRV 2500 ml, right? So now we have to mention here inspiratory capacity. Inspiratory capacity equal to what? Means, I'll mention again here. If not, we can do there only. Right? Inspiratory capacity equal to what? PV plus IRV, right? PV plus IRV equal to how much? 500 plus 2500, how much? 3000, right? And the same thing, 500 plus 3000. So 3500, it means 3000 to 3500 is the inspiratory capacity. Guide all of you. 3000 to 3500 ml is the capacity of what? Inspiratory capacity. Got it, all of you? That was good. Over. It's about inspiratory capacity, right? Good. And next one. Next one. Expiratory capacity. Right? Expiratory capacity. Quite reverse to this, right? What we did here, you can do forceful inspiration, but after normal expression only, right? Now you have to do what? Forceful expression after normal inspiration. Show it here. Okay, this one forceful expression. Okay, then after normal inspiration, right? It's about normal inspiration. So now you have to do what? Forceful expression. After normal expression, you have to do forceful expression. Mean from here to here, right? After normal expression, you have to do forcible expression. That is what expiratory capacity, EC. Could you please check what is included here? Again, this is the one volume, tidal volume. Plus, what is it here? ERV. Very good. How much? We have to mention the right. How much? PV plus ERV. Tidal volume is equal to 500 ml plus ERV equal to 1 is the 1000 ml and another one is 1100, right? 1100 1000. It means it means almost 1500 to 1600 ml is the expiratory capacity. Got it? Good. And next one. After that, we have to go with what? Functional residual capacity. What is it? Functional residual capacity. Good. Okay then. What is it? Here, what is it? Even after forceful expression, you are doing here forceful expression. Got it? Okay then. After forceful expression, also remaining amount in the lungs is called as residual volume. Got it? But after normal expression, mean how it is? Okay, it's about normal expression. This is normal expression, right? After normal expression, the volume of air remaining lungs, that is called as what? FRC. Mean. So after normal expression, okay, it's about expression normal. It's about normal expression. After normal expression, the volume of air remaining in the lungs is called as FRC. Here you can see that. Means from here to here, right around. This is what FRC. Could you please tell me what is included here? What is included here? After here, right? What is the here? This one ERV. What is this one? RV, right? FRC equal to ERV plus RV. Based on that, we have to find out ERV equal to how much? Measurement we have to take, right? 1100 ml and RV equal to 1200 ml, right? Okay then, right? So ERV equal to ERV plus RV equal to FRC. Got it? ERV means how much? Major amount 1100 ml and here 500 ml. Means 2300 ml is the functional residual capacity. Got it? Over, right? At last two, that is about the total lung capacity, and next one vital capacity. What are those? Listen, is one, right? What is the first one? We have discussed vital capacity. What is vital capacity? Last one I am going to come in, right? Vital capacity. It means we have to do like maximum volume of air a person can breathe in, inspire after forceful expression. Means first you have to do forceful expression up to here, right? And then you have to do what? Forceful inspiration. Means from here to here, right? Now you have to do. Now you have to do forceful inspiration. That is what. Definitely you know about it. It's about forcible expiration, right? So from here to here, this is called as what? Vital capacity. Could you please tell me what are the included here? What are the parts are there? First one, VC equal to ERV plus TV plus IRV. Right? Good. VC equal to first one ERV, because of started from here, right? It's what? ERV box, right? And next one is what? TV plus this one up to here, right? IRV. And could you please tell me about that? Total lung capacity, right? Means the vital capacity equal to how much, right? So what are those? ERV. ERV plus TV plus IRV. You know very well. ERV is how much? Definitely major amount. 1100. It's about 500, 1600, right? And IRV, how much? 1600 plus the 3000 almost, right? How much? 4600 ml is the vital capacity. Got it? Right, all of you? So VC equal to almost 4600 ml. At last one for today, that is what? Total lung capacity. Total lung. Right? You know what? What is the definition? I will tell you that. Total lung capacity. Here, right? Total lung capacity means you have to do now. This is what force inspiration. Now, what is the volume of air remaining in lungs? Right? So after force inspiration, mean what is the volume of air remaining in the lungs? That is called as a total lung capacity. That is what showing this way. Right? This is what, right? Right? So it started from here to there. Total lung. It should be total of our lung, right? So could you please tell me what are the factors are including in that? What are the factors are including from that, right? So that's about PLC, total lung capacity equal. What is the parameter is? What is the box? TV plus ERV is the box, right? Plus TV plus IRV. And could you please tell me what the total amount? TV equal how much? TV. First one, 500, right? What is it here? Like it's about RV, not TV, it's about RV. What is the RV? 1100. Okay. So major we have written, right? 1200 plus. Next one, ERV how much? 1100 plus TV how much? 500 plus IRV is almost 3000. How much? 3000 plus 500. 3500 plus 1100. 4600 plus 1200. 5800. Almost I mentioned here 6000. Right? So that is what main our lung capacity. Total lung capacity is equal to 5800 ml, means 5.8 liter is the capacity of our lungs in the case of adult, not in the children, right? Not in the even diseased persons also, right? Now my lung capacity is about 6000, almost 5.8 means 6000 ml is the capacity of my lungs. Everyone almost after 12 years, right? This is what about respiratory volumes and capacity we have, right? So that's first one, tidal volume. Next one, IRV, inspiratory capacity, ERV, expiratory capacity, and next one, RV. We have the coincidence, like you can spot like difference in between residual volume as well as FRC. Residual volume means After forced expression also, our lung have some amount of air. That's about residual value. You can't remove. FRC means what? FRC means what here? Like after normal expression. Here doing after forced expression this is what? After normal expression this is what? Both are right. So one is ERV plus RV equal to FRC. Got it? This is what today topic such as respiratory volumes and capacities. Right? Thank you. Thank you very much.